So I am Akshara and I am going to share a few quotes today. Hard work beats talent when the talent doesn't work hard. This is a quote said by Tim Notke. And the other quote is preparation for tomorrow is today's hard work. This is a quote said by Bruce Lee.
If you plot between in a RLC series circuit, consider that RLC series circuit. If you plot between frequency and current, when the current will be maximum? At omega naught. At omega naught, current will be maximum. F naught or omega naught. Current will be maximum. These two are called off power points. That is called omega 1 and omega 2. Here, the current is I max. Why it is called I max? Because it is at resonance, current is maximum, that's why I max. Here, the current is Im by root 2. I max divided by root 2. Here also, the current is Im, I max divided by root 2. If you find power at this point, power equal to what? Power equal to I max divided by root 2 whole square multiplied by R. That is I max square R divided by 2. This is power at resonance. So at this point, power is P means here power is P by 2. Here power is P by 2. That's why these 2 points are called off power points. The frequency at off power points are called omega 1 and omega 2. These two are cutoff frequencies. Another name for omega 1 and omega 2 are called cutoff frequencies. The difference between omega 1 and omega 2, that is omega 2 minus omega 1 is called bandwidth. Omega 1 to omega 1. The difference between omega 2 and omega 1 is called bandwidth. We can prove that omega naught equal to square root of omega 1, omega 2. We can prove. Let us prove. What is current at omega 1? What is current at omega 1? I max divided by root 2. That is, let us assume that current at this point is I1. Current at this point is I2. I1 equal to what? I1 equal to V by Z1. Here, V divided by root 2 times Z naught. Can I say like that? Can I say like that? Because at Z naught, V naught by Z naught is I max. I max divided by root 2 is I1. We know already. That's why we can say that root 2 times Z naught. Or I can say that Z1 equal to root 2 times Z naught, that is equal to root 2 times R, I can say. Because at Z naught, Z equal to R. Z naught is equal to R. That's why I can say that Z1 equal to root 2 times R. Modulus of Z, we cannot say like this. Modulus of Z1 equal to root 2 times R. Because at Z1, XL is not equal to XC. At Z1, XL is not equal to XC. At Z1, at omega 1, XL is not equal to XC. That's why it is a complex number. It is a complex number. But if you find modulus value, that is root 2 times R. So this can be written as, therefore, Z1 can be written as R plus JR. If you find the modulus of Z1, what you will get? Root 2R. What is modulus of Z1? Equal to R square plus R square. That is equal to square root of, that is equal to root 2R. Modulus of Z1 is root 2R. R plus JR. Therefore, the difference XL minus XC equal to JR. Therefore, at omega 1, at which is dominating? At omega 1, which is dominating? XL or XC? XC. We have to remember the diagram. We have to remember the plot. If you remember the plot, lower frequency XC will be larger. Therefore, the difference we have to write 1 by omega 1C minus omega L equal to R. Why I wrote like that? Because JR, this is the complex value, J equal to JR. Complex value equal to 1 by omega 1C minus omega 1L. Similarly, the other side, at omega 2, we can write which is dominating? XL dominating. That's for omega 2L minus omega 2C equal to JR. We can equate these two. These two are equal. Therefore, I can write 1 by omega 1C minus omega 1L equal to omega 2L minus omega 1 by omega 2C, because both are equal to R. That's why we can equate these two. If you bring C and L one side, you will get 1 by omega 1C plus 1 by omega 2C equal to omega 2L plus omega 1L. Or we can say 1 by C, 1 by omega 1 plus 1 by omega 2 equal to omega 1 plus omega 2 multiplied by L. If you take LCM, you will get omega 1, omega 2 equal to omega 2 plus omega 1 multiplied by equal to omega 1 plus omega 2. If you bring that C here, you will get LC here. These two getting cancelled. Therefore, 1 by omega 1, omega 2 equal to LC, or 1 by LC equal to omega 1, omega 2. But we know that 1 by LC is omega naught square. Omega naught square equal to omega 1, omega 2. Therefore, omega naught equal to square root of omega 1, omega 2. Or the resonant frequency is geometric mean of cutoff frequencies omega 1 and omega 2. Hence proved.